Histograms come up a lot in exams. They're a common exam question topic and they can often be worth quite a few marks. Now I'm going to split this topic up into two videos. This video is going to be going through histograms and how they work essentially, and then I'm going to upload another video going through a load of past paper questions on the topic, okay? So histograms are used for grouped frequency tables like this here. When you have a grouped frequency table, you can convert this into a histogram. So, as you probably remember from GCSE, a histogram kind of looks like a bar chart, but in a bar chart, the frequency is determined by the height of the bar, where in a histogram, the frequency is determined by the area of the bar. So, this here is a histogram where on the x-axis you'll have some sort of measurement, and on the y-axis you will have the frequency density, okay? So, let's find the frequency of these two bars here, so we need to find the areas of them. So, let's start with this one here. So it goes from 0 to 4, so the width of the bar will be 4, and this is multiplied by the height of the bar, which is 20, and 4 times 20 is 80. So this is the frequency of this bar here. Now if we look at this one, so it goes from 4 to 14, so 14 minus 4 is equal to 10, so this is the width of the bar, so it's going to be 10 multiplied by the height of the bar, and you can see that this comes up to 10, so it's going to be 10 times 10, which is equal to 100. So the frequency of this bar here is 100, and this is what I mean by a histogram. The frequency is not determined by the height of the bar, because this bar here is taller, but it's actually got a lower frequency than this bar here. So a new concept at A level is that the area of the bar may not be equal to frequency, it may be proportional to it. So what do I mean by that? So let's go through this example here to show what I mean. So the histogram below, which is this histogram here, shows how many hours of sleep 100 people got on a particular night, and we need to find the number of people who got more than 6 hours of sleep, okay? So this is going to be represented by this bar here because this is more than 6 hours, okay? So we need to find the area of this bar, okay? So the width of it, so it's between 6 and 10, so the width is 4, and this is multiplied by the height, which comes up to 8, so the height is 8, and 4 times 8 is 32. So the area of this bar here is 32. So you might be thinking that this is the answer. There are 32 people who got more than 6 hours of sleep. However, if you look at this bar here, so if we figure out the area of this bar, so it's between 0 and 6, so the width is 6, and the height of the bar is 3. So it's 6 times 3, which is 18, okay? Now, if you do 32 plus 18, this is equal to 50. So this is the total area of this histogram. However, you can see that there are 100 people in the data and we only have an area of 50. In this case, the area of the histogram is not equal to the frequency. What we're going to do, so we have 100 people, and we're going to divide this by the total area, which is 50, and this is equal to 2. Now this number here, we call this k, and this is essentially a scaling factor. What this means is every 1 unit of area in this histogram represents 2 people, because there is an area of 50 in the total histogram and there are 100 people. So that is what I mean by the area of the bar may not be equal to the frequency, it may be proportional to it. In this case, each unit of area in this histogram represents 2 people. So in order to get the number of people who got more than 6 hours of sleep, this area here, 32, we just need to multiply this by the scaling factor, which is 2, and this is equal to 64. And this is the number of people who got more than 6 hours sleep. Okay, now another thing that you could be asked with histograms is to draw something called a frequency polygon. Okay, so the way that you do this is for the bars in your histogram, you are going to find the midpoint of each bar. So for this bar here, the midpoint is here. For this bar here, the midpoint is here. For this bar, the midpoint is here. For this bar, the midpoint is here, and for this bar, the midpoint is here. And you're going to connect all of these points with straight lines. So these 2 points here, we're going to connect like this. These 2 points here, we're going to connect like this. these 2 points we're going to connect like this, and these 2 points we're going to connect like this. And this here is a frequency polygon. Obviously you use a ruler in an exam. I can't really do that on a laptop, okay? So don't include any gaps at the start, only start it at the first bar like this here. So here's another example. So here, the midpoint of this bar is here, the midpoint of this bar is here. Now, if you have a gap between two bars, you do include this gap. So we're going to say it's here, this midpoint, and then we have another bar here, and then another bar here, and then another bar here, and then another bar here. So if we connect these points, it's going to be like this, and then 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 like this, and this is a frequency polygon. Now, I don't know if you need to be too aware of this at A level, but the actual purpose of frequency polygons is it can be useful to compare data for two different histograms. Kind of comparing the bars on two different histograms can be kind of difficult, so comparing their frequency polygons can be a bit easier, but I'm not sure they're really going to ask you about this at A level. Okay, I just want to mention one final thing in this video that comes up quite a lot in exam questions, and I think this exam question here, this is sample paper 2, question 2 in the AS course. I think this question shows it quite well, and it comes up quite a lot. So in this question, we're told the partially completed histogram and the partially completed table. Now, part of this question is to actually complete the histogram and to complete the table. For the purposes of this video, I've done it for you. So here we just have a histogram and we have a table that show the time to the nearest minute that a random sample of motorists was delayed by roadworks on a stretch of motorway. So we have this grouped frequency table here. So this is when they were delayed between 4 and 6 minutes. This is when they were delayed between 7 and 8 minutes. And this is when they were delayed between 9 minutes and so on. And then this is a histogram representing this data, okay? Now let's look at the 4 to 6 minute range, okay? And let's look at the bar here in the histogram, which is this one here. And the width of this bar is quite weird because this is between 4 and 6 minutes, but you can actually see that this bar here starts a bit before 4 and it ends a bit after 6 as well. In fact, it starts at 3.5 and it ends at 6.5. So why does it do this? It's because of this detail here. We're told the time is rounded to the nearest minute, and what this means is this here is not the true interval. The true interval, so if we're rounding it to the nearest minute, the lower limit is going to be 3.5 minutes, because if you're rounding it to the nearest minute, 3.5 if you round it to the nearest minute is 4, so this is going to be included in this interval as well. And then the upper limit is going to be 6.5. Now 6.5 isn't actually going to be included because 6.5 will be rounded to 7, so it'll be in this interval instead, but anything below it will be rounded in this interval here between 4 and 6, and this is why we get this width here, because the actual interval is between 3.5 and 6.5, and you get this for all of the bars in the histogram. I just wanted to mention this because they quite like asking questions about this, and it's something that students miss out on a lot. If it's rounding it to the nearest minute, there is a good chance this here is not the true interval, this here is, and it's represented in the bars in the histogram.